This is 2.1 student notes, and this is on functions. Okay, we're going to start out with a function notation. So let's start with f of x, and that's going to be equal to 3x squared plus x minus 5. Remember, the only thing I need to do to make this as an equation is to replace the f of x. Okay, so if I start off with my first problem, I would say f of negative 2. And in order to work this problem, all we need to do is plug in my negative 2 in for every value of x. That simplifies to 12 minus 2 minus 5. And then that's going to give me a final answer of 5. Now, I do expect you to be able to do this without a calculator. Even if this was a harder number like a half or 3/4, okay, you should be able to do that without. Okay, let's try something different. How about f of, let's try f of a. Just something easy there. Okay, so this definitely is an easier problem. I just want you to substitute the a in for all my x values. So that's just going to be 3a squared plus a and minus 5. And that should be your final answer. Can't do anything else to that. Okay, the next one, C. How about I say f of a plus 2? Hopefully y'all are kind of rushing through these. Let's substitute an a plus 2 in. Now the biggest thing I think people forget is right here. I'm going to have to distribute, or I'm going to have to FOIL. And I'm going to try to do that at the same time. So that is going to give me a value of, let's see, maybe I shouldn't do that at the same time. Let's do 3, and I'm going to FOIL that. So that's going to give me a squared plus 4a plus 4, just to not confuse people. Then I don't need my parentheses here, so this is a plus 2, and then minus 5. So distributing the 3 gives me 3a squared plus 12a, and then plus 12. I still have my a, and let's subtract these. Simplifying one more time, this gives me 3a squared plus 13a, and this is going to be plus 9. And that should be my answer, just simplified. How about on D, I move my number on the outside and say 2 times my function f of x. And just like I just said that, I want to double my function, so I'm going to bring down my function and double it. So I'd write 2 times my function, which is 3x squared plus x and minus 5. So if you distribute that, that's giving me a 6x squared plus your 2x and minus 10. All right. My next problem, if you haven't done your after party, is going to help you out on that. So some of y'all are going to be very lucky on that. So E, I'm going to write f of, this is a plus h minus my f of a, and I'm going to put this all over h. Now, we are going to be using this a lot. You're going to see this a lot next year in calculus, and I'm going to explain a little bit more of this later on, but let's try to get through this process here. Okay, so the first thing, it says f of a plus h. So you're going to kind of work this as two separate problems and squish them all together. So that means I'm going to take the f of a plus h, and I'm going to substitute it in to my function. So this is going to be 3 parentheses a plus h squared plus, instead of my x, I'm going to have an a plus h and then minus 5. So this represents my first part of my function right here. Now I'm going to subtract f of a. So this is going to be 3 a squared plus a, and then minus 5. So this is the second part of the function. And then all of this goes over h. And you do need to write that as well. Okay, let's start simplifying. Now above we factored or simplified this. Remember, this requires you to FOIL or distribute. So I'm going to distribute and go ahead and factor in the 3 as well. So I'm going to do 2 steps here. Okay, so this is going to be a 3a squared plus a 6ah. Now remember, I'm FOILing and distributing the 3. This is going to be plus 3h squared. Okay, now I'm to the plus a plus h, and this is minus 5. This is the first part of my function. Now I'm going to distribute my minus or my negative in, so minus 3a squared minus a, and this is plus 5. And I still have it over h. At this point, you should be able to cross out some problems. In fact, most of the time, the second half of your function, all of these numbers are going to simplify. So I have a plus 5 and a minus 5. I have a positive 3a squared and a negative 3a squared, and a positive and a negative a. So rewriting what I have left over, I have a 6ah, I have a 3h squared, plus a plain Jane h, and that's all over h. You should notice they all have an h in common. I cannot just cross it out, but I can factor it out. So if I factor out an h, that gives me a 6a plus 3h plus 1 over h. And now these h's on the outside cancel. And I'm down to my last of my problem, which is 6a plus 3h plus 1. And this is my final answer. Piecewise functions, you have worked with them before. I just want to kind of talk about a few of them. Let's look at a new function. How about, let's do a g of x. Now remember, when you're writing a piecewise function, I'm just going to write 2 of them here. So you do your open bracket, and how about x squared, where your x is less than 0, and I'm going to do an x plus 5, where your x is greater than or equal to 0. Remember, they can't both be equal to 0. Okay, on my first function, or my first problem, let's do g of 2. On g of 2, basically you're not going to plug it in both of these places. Where does 2 fall? Is it less than 0, or is it greater than or equal to 0? And in fact, it falls in this function. So I'm going to plug in a 2 here, and then my answer would be 7. Easy as that. All right, my next one, how about, let's say g of negative 3. And where would g of negative 3 fall? It's going to fall right here. Now remember, we're placing the x value, so I'm going to use parentheses and then square it. And so my answer would be a 9. And again, not using my calculator for these. For c, let's try g of 0. Now because I want exactly 0, I'm going to use my second function because it is equal to 0. So that would be 0 plus 5, which is just 5. Okay, we have talked about domain. I want to look at some domains of functions that are kind of strange. So I want to look at the domain for the function of y equals the square root of x, and the domain for the function y equals 1 over x, and y equals log x, or you might see it as y equals the natural log of x. And we will get into these a lot more later, but I just want to kind of talk about the domain of them, okay? And I'm just kind of brushing the top of some of these things. Okay, so the square root of x, we've talked about the graph, and I asked you to look at the graphs because you really need to know these. So the graph of this if you talk about the domain, the parent function is going to be greater than or equal to 0. That means if I write it in interval notation, it's going to be equal to 0, and then it's going to go to infinity. Now again, I can have some shifts in this, some movement, but this is the parent function. Now this is a rational function, so the parent cannot be 0 because I've got some asymptotes. So I would say that I've got negative infinity to 0, and then because of the asymptote, I'm going to say a union from 0 to infinity. Okay, the log or the natural log, I have some asymptotes as well. So I'm going to say x has to be greater than 0 for my parent function. So I'm going to go from 0 to infinity. If I have, for my first problem on this, f of x is equal to 1 over x squared minus x. The first thing that you should probably do on this problem is factor it, because they both have an x in common. So I could say 1 over x parenthesis x minus 1. Now remember, on the bottom of a fraction, you cannot have a 0, and that's basically your vertical asymptotes. So I always set those to 0. So x is equal to 0 and x is equal to 1. Okay, so x cannot be those because those are your vertical asymptotes, right? So in order to write your domain, this should be really easy because you're going to have a domain or a vertical asymptote at both of these places. So that means that you can have you're going to have a number anywhere except for these. So that means I can go from negative infinity to the number that I'm going to go next would be what? 0. Then I'm going to pick back up and go from 0 to, I can go from between 0 and 1. Looks like I'm going to have another union and go from 1 to infinity. So if you were to do test points, you can do those if that makes you feel better. I really don't care what this graph looks like. I just know that I've got vertical asymptotes here and here, and those are the only two places that I cannot have part of my graph. So this is my domain for this rational function. Okay, how about if I give you f of x is equal to the square root of 2x minus 3. Now remember, on these, this is a square root function, and I said this was the parent function, but it can be moved. So on this, I said x has to be greater than or equal to 0. So let's look at this. So basically, I can take the square root of 0, but I cannot take the square root of a negative number. So that's why I take the 2x minus 3, and I set it greater than or equal to 0, because 0 is okay. And let's solve it. So this should give me my answer that will make this false, basically. So x has to be greater than or equal to 3/2. Okay? Any number that's greater than or equal to 3/2 will make this problem okay. If I go less than that, then I'm going to have a negative number underneath my square root, and that's going to give you an imaginary number, if y'all remember that. So in order to write my domain for this problem, I would say that I can be equal to 3/2, because that again's going to give me 0, and 0 is okay. And then I'm going to go to infinity. And that is the only thing I can do for that one. Now, remember, if you happen to multiply or divide by a negative number, that's going to flip your inequality. Let's see. How about f of x is equal to x over the square root of 1 minus x. Okay, so I'm combining a fraction, which you can't have zeros on the bottom, and I'm combining a square root. So let's look and see what we need to do here. If you can't have a 0 on the bottom, of course, I would say 1 minus x and set that to 0. So 1 cannot equal, or x cannot equal 1. And you have another restriction here. Remember, when the square roots, you're going to say 1 minus x has to be greater than or equal to 0. So in this case, I would solve this problem. That gives you a -1. I'm dividing by a negative here, so x has to be less than or equal to 1. Now, I've got to make my domain true for both of these. I'm going to say this goes from -infinity to 1, but I'm not going to include it so that I can make this one true as well. All right. And let's make this our last one. How about f of x is equal to the square root of x squared minus 2x. Okay, so it's under the square root. So I'm going to say x squared minus 2x is greater than or equal to 0. Now, you could move your 2x over. How about we factor? I'm going to take out an x and see where this leads me. Okay, so this factors down. This gives me all that I need. Now, this is a square root, or I'm sorry, this is a quadratic. The easiest thing that you could do here, you know that you're going to have 0, and you know you're going to have 2. Personally, I would take my number line, I would plot 0, I would plot 2. It is greater than or equal to, that means that you're going to have a closed circle. And if you were to plot a quadratic, it would look like this, opening up. Well, what's greater than means that you're going to shade this part of it, or that means that you would shade on the outside here. Okay? Or you may do test points, and test points are going to give you this outside area as well. So my domain for my last problem, I know we didn't hit every problem possible, but hopefully this is going to help you get through your homework.